Welcome to Knowledge Gainer 1 channel. Today our topic is second chapter, that is sets of 10th class. We represent the natural numbers with n, that is 1, 2, 3 and so on. The whole numbers we represent with w. The whole numbers are 0, 1, 2, 3 and so on. Integers we represent with I or z, that is 0, plus or minus 1, plus or minus 2 and plus and minus 3. Rational numbers we represent with q, the numbers that can be written in the p by q form. Here p and q are the integers and q should not be equal to 0. Generally, we represent sets in two forms, that is roster form and set builder form. Let us see some examples. First one is set of all natural numbers less than 5. In the roster form, all the elements are written individually separated by commas in the flower bracket, that is 1, 2, 3, 4. The set builder form, the set is described by a representative and stating the property of the elements in which the set satisfies. Here, take a set A is equal to, keep the flower bracket, take a representative x. X belongs to the natural numbers n and x should be less than 5. This is the set builder form. The second set is set of all the letters in the word April. Now the roster form is A, P, R, I, L. This is the roster form. Next point is empty set or null set or void set. Here this set does not contain any element. So this is called as empty set. We denote it by this or empty flower brackets. Singleton set. In this, the set contains only single element, that is 0 or sun. Sun is only 1, so sun is a single set. Next set is finite set, that is the number of elements in this set can be counted. The number of days in a week is 7. Here the set of days in a week, that is Monday, Tuesday, Wednesday, Thursday, Friday and Saturday and also Sunday. Here the number of days in a week is 7, that is countable. So the set of days in a week is a finite set. If in a set the number of elements can't be counted, then it becomes the infinite set. Example is j is equal to, this is a set builder form, x is a multiple of 7. Here 7 ones is 7, 14, 21, 28 and so on. There is no end for the multiple of 7, so this is the infinite set. Equal sets. Two sets are said to be equal if they have same number of elements and the elements should be same. That is, here the elements in the set A are 1, 2, 3 and also the elements in the set B are 1, 2, 3. So the set A is equal to B. Both these are equal sets. The number of elements in a set is called as the cardinal number. Consider the above set A, 1, 2, 3. Here the cardinal number of the set A is n of A is equal to 3. Universal set. Universal set is a set which contains all the sets under consideration. Let us take the universal set as the alphabets. Let us consider alphabets is the universal set and we denote it with U or this symbol. Here, if we consider the vowels set and consonant set, every element in this sets belongs to the alphabet set. Generally, we represent it with the rectangle, vowels and consonants. This is the universal set alphabets. The next one is subset. Consider two sets A, 1, 2, 3, B, 1, 2, 3, 4, 5. If every element of A is present in B, then A is the subset of B. We represent it with A is subset of B. And B becomes the superset of A. Some important points. Every set is a subset of itself. Empty set is the subset of every set. If A is subset of B and B is subset of A, then A and B becomes the equal sets. If A is subset of B and B is subset of C, then A becomes the subset of C. Some basic operations of sets are union of sets. Let us consider two sets A and B. Let us consider the set A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5. A union B can be represented by A union B. Now to find the A union B, first of all, union of sets is we should take the individual element and also the elements which are in common. That is A union B is equal to, the common elements are 1, 2, 3 and also the individual elements are 4 and 5. The Venn diagram representation of union of sets is we should take the elements in common and also the elements in each set. So this is the Venn diagram representation of A union B. The next one is intersection of sets. We represent it with this symbol. Now A intersection B is we should take only the common elements which are both in, that is which are both in the sets. So 1, 2, 3. 4 and 5 are not there in A. So we should take 1, 2, 3. This is the intersection of the two sets A and B. Now the Venn diagram representation is We are taking only the elements which are in common in both the sets. So we should shade only the common portion. This is the A intersection B Venn diagram. The next one is disjoint sets. Let us consider two sets A 1 2 3 and B 4 5 6. Now the disjoint sets are the sets which doesn't have a single element in common. Here in sets A and B, no element is same. So from this we can conclude that A intersection B is equal to null set. Now the Venn diagram representation of the null sets A and B is, take this as A and there is no element in common. We should not overlap A and B. The next one is difference of sets. Consider two sets A and B. A is 1 2 3 4 and B is 3 4 5 6. We represent the difference of sets as A minus B. Now the difference of set A minus B. Now we can take A minus B as, we should take the elements which are present only in A. We should not take the common elements also. We should not take either 3 or 4. We should take only 1 and 2. Now the difference is B minus A is, in this we should take only 5 and 6. The elements which are present in A should not be taken. So 5 comma 6. Here A minus B is not equal to B minus A. Now the Venn diagram representation of A minus B is, we should take only the elements which are present in A. That is, we should shade this portion only. We should not shade the overlapped portion. Now Venn diagram of B minus A is, we should take only the elements which are present in B. So the shaded portion should be only B part. We should not shade the common part. Let us see a note point. A and B are any two sets. Here the cardinal of A union B is cardinal of A plus cardinal of B minus cardinal of A intersection B. Let us see an example. Here let the set A be 1 2 3 4 and set B be 3 4 5 6. Now n of A is, there are 4 elements 4. Now n of B is also, there are 4 elements. So cardinal of B is 4. Now A intersection B is, we should take only the common elements, that is 3 and 4. So n of A intersection B is 2. A union B is, we should take the common elements and also the individual elements, that is 1 2 3 4 5 and 6. Now n of A union B is 6. Let us substitute these values in this formula. N of A union B is 6 is equal to 4 plus 4 minus 2. 6 is equal to 6. Thanks for watching. Please like, share and subscribe to Knowledge Gainer 1M channel and also share with your friends. Press bell icon to get notified.